After Colt took over the AR-15, now renamed the M16, you continued designing small arms. When did you leave Armalite, and where did you go from there?
I left Armalite soon after Fairchild Aircraft decided that they were going to get out of the small arms thing and they were going to sell Armalite. And the people that were in line to buy it, I didn't get along with that well and decided I would go elsewhere, so I just did consulting work for a while. And then I ended up, I was contacted by Cadillac Gauge Company to design a small arms for them, and that's where I went after that.
And that became the Stoner 62,
60,
later 63 system.
right.
What was the concept behind the Stoner 63 system that you developed for Cadillac Gauge?
Well, the basic concept was the fact of using a common basic mechanism and be able to take that, meant the receiver group, the bolt group, the trigger group, and convert that into several types of weapons because they are so similar. Like your machine gun, which is here, and the rifle have a lot of very common parts, but historically no one had ever really tried to use the same commonality. And what I attempted to do was design a system from scratch that would use this commonality. And so the system uses the same basic receiver group, bolt group, trigger group, and by the change and addition of a rifle barrel, sights, and so forth, make it a standard assault rifle. And then by just pushing pins, which you see here, be able to rotate this receiver over and put on it a belt feed mechanism, which you see here. Receiver is rotated upside down what it is in the rifle, and actually then use all this basic mechanism then with the addition also of a heavy barrel to take the extra heat input and make yourself a machine gun. Now there are also some little tricks and gimmicks in the bolt group that makes it fire from an open bolt machine gun and a closed bolt in the rifle, but it still uses the same basic parts and mechanism to do it. So that was the whole theory behind the 63 system, was to make a complete family of weapons out of one basic unit. And we succeeded in doing that.
And this was manufactured by Cadillac Gauge up in Warren, Michigan.
Right.
NWM also had the Netherlands also had a marketing agreement for that?
They had a license agreement and also a marketing agreement to manufacture for certain European countries and also to sell over there.
It's a good design. Why didn't it sell?
Well, I think there again, the timing is everything. Ran into, first of all, at the time I was doing all this, I really couldn't foresee the continuing popularity of the M16 rifle, and the fact that I recognized also at the time we needed a small machine gun. Now, a lot of people disagreed because they figured the machine gun roll would never be scaled down. It would have to remain something like the 7.62 or the M60 type machine gun. And I always felt, due to the fact that I believe combat missions and ranges are much shorter than a lot of people, that the small machine gun did have a place. So I brought this idea out, and Cadillac Gauge people at the time, the management, thoroughly agreed with this concept and had some experience in marketing around different types of armament for armored cars and so forth. But the reason I think for the failure of it, the Marines absolutely wanted the system. It met their basic requirements. They had a requirement written around the family concept. And at the time that the Commandant of the Marine Corps, the person there at the time, was fully behind it, endorsed it, and everything was rolling along real well until the Army was told to do the procurement and also the final specification and testing. And I tried to warn the Marines that there was going to be a little bit of animosity involved there, but the Army convinced the Marines they had no business in that procurement end of it, that they knew better, so therefore took that part over. And the Army was particularly interested in the machine gun version. And they kind of pushed that, and they rather ignored the rifle because they were trying to sell the Marines on the fact that they could adopt the machine gun but keep the M16 rifle, and the Marines didn't want to do that. But anyway, that became a big issue. And to make a long story a little bit shorter, there was quite an involved test program that was conducted by the Army on their own, by their own rules, and they made very, very sure that the machine gun didn't measure up to their requirements. Although the Marines had stated that their testing had shown that it met their requirements, but the Army said, well, if you want this to be universally accepted, you're going to have to meet our requirements. So they set their own requirements on the thing. And they did it rather arbitrarily, and it created quite a few problems, such as they got the Marines to agree to a test plan, but then I didn't even see the test plan until it was all over with and agreed upon, and then I saw a lot of particular holes in the test plan. And for instance, they got the Marines to agree that the weapon would not be sensitive to ammunition variances. And the Marine says, well, we've tested with many, many lots of ammunition. We've never had any problem with it. The Army says, let us show you. So they took the belt-fed machine gun, for instance. The tracer rounds were very limited production. They were very unsatisfactory and only used a little bit in Vietnam for squad leader spotting. But they never were fired in machine guns because this was the only belt-fed machine gun around. And they had very low gas port pressures, so they barely function a weapon. And they took this opportunity to search out all the different lots of ammunition ever made, and they got the weakest port pressure measurement that they could ever find on the tracer round, which was bad to begin with, and they got the highest port pressures ever recorded excuse me, on the ball rounds, and proceeded to mix the belts and do the testing that way. Excuse me. So that was an abnormal test, in my opinion, when you searched and got the absolute worst and the absolute best. And I found that there was a lot of new tracer ammunition that was really designed for up-and-coming machine guns, and identified the lot for them to test. And that whole lot disappeared overnight. No one ever found trace of it afterwards.
Was that part of the SAWS test?
That was only the beginning of an engineering part. This was done at Rock Island.
Okay.
So the report that came out of that disappointed the Marine Corps, and before we could recoup and regroup, I found out that the Army was designing their own belt-fed small caliber weapon. And I knew what was happening. I knew that they were going to be the competition, and they were going to be the people to test it. It was the same group, the same engineering group out of Rodman Laboratory that were doing the whole thing. And I felt compelled to tell the management of Cadillac Gage that this was getting to be an impossible situation. They were finding some faults with the weapon. They demanded that Cadillac Gage change the weapon and design, spend a lot of money. They did this several times, and then I ran into this proof positive that they had a weapon of their own that they were going to introduce. And I told the president of Cadillac Gage that I thought he was probably wasting his time unless we could get it away from this group.
Was that the Rodman SAW?
Yes. And in the meantime, though, another critical thing, the commandant's job changed in the Marine Corps, and the Marine Corps immediately became more interested in Harrier jets and things like that, and they lost interest in the thing. So the timing window kind of went by the wayside.
Now, taking you back for a second, in 58, 59, when the Army didn't like the 5.56 for the rifle, they proposed the 6.35 millimeter intermediate cartridge.
Right.
Okay. And as you say, there were multiple case lengths in that round, so it was very confusing. Now we're up to the end of the 60s, and the Army comes up with a new intermediate round, the 6 millimeter saw round, because it is, again, sort of halfway between 5.56 and the 7.62 NATO.
Mm-hmm.
What was your reaction when not only did they unveil that they had a new gun, but they had yet another caliber?
Well, my reaction was we were doing the same dance all over again, that the reason for the 6 millimeter was to get rid of any existing 5.56 machine guns, mainly this one. In the meantime, Colt had one that they were working on, and meantime also the Belgians were working on one. And there was no secret, everybody knew this was going on. And so what I figured, the tactic was just exactly the same it was before. They'd introduce another caliber, and they'd have the only ammunition, which was theirs, it was done in-house, and they'd have the only gun. And they were trying to convince the Army that this was the ideal small caliber machine gun. We were going too far with the 5.56. We should only go to the 6 millimeter. And the problem we ran that also presented itself was the fact that Cadillac Gage was, to stay into this competition, had to go and build a 6 millimeter. In other words, completely retool. There were several $1 million in tools invested here. Completely retooled the thing in order to have the privilege to compete with an in-house gun. Well, Cadillac Gage's management did just exactly like almost any other management would be, where you're trying to call the dollar flow and all that. And they said, no, enough. And they refused to do this. So what happened was the competition dropped out completely. The Army then tried to run this round up, went through the motions, that's about all it was, up through the staff levels. It got to the Chief of Staff of the Army, and he laughed about the whole thing and said, this is ridiculous. You're not going to enter into another round in between the 5.56 and the 7.62. He said, forget it. Well, the Army did forget it, but it accomplished its purpose. It got rid of all the competition at the time. So then Rodman went back and started making their weapon in a 5.56 machine gun. They'd already eliminated Cadillac Gage.
Okay, we need to stop there. Great. Looking at the 63 system, it's obvious that it employs different manufacturing techniques than the M16 AR-10 predecessors. Why did you go to sheet metal stampings in this particular weapon? What were you trying to accomplish?
I'm sorry, could you do that question again? I had a problem here. Okay. Sorry about that.
No problem. In looking at the Stoner 63 system, it's obvious that it uses different manufacturing techniques than were used in the AR-15, AR-10 series. What were you trying to accomplish by using sheet metal stampings and other processes?
Well, basically, the idea of this thing was going to be an all-purpose weapon with a fairly large volume of production. I try to get something that would be as economical as possible to produce, realizing you're trading off weight to do this. In other words, it's heavier than the aluminum construction. One of the other reasons is the fact that in demonstrating and showing the M16 AR-10, we found out there were a lot of countries that were interested in building a weapon like that, but didn't have the technology to make aluminum forgings, which you wouldn't think would be much of a technical problem, but at that time it was. And also the fact that some companies, such as some of the German companies, were having quite a bit of success in selling the idea of the sheet metal weapons as being the way to go because they were cheaper, and especially in wartime conditions. They didn't have any critical materials or anything like that. So I picked up on that and decided to go that direction. I realized at the time getting into it that the tooling costs and everything were going to be considerably more. The 62 version, the predecessor of these 63s, really was the similar techniques of the M16 using aluminum. But as we got into it, and as Cadillac Gauge said, they didn't see anything particularly wrong with going to the sheet metal construction. They were in the Detroit area where, stamping out cars was no big mystery. And so they endorsed this idea too, so we went ahead with it. But there are a lot of little subtle things that one doesn't realize when you go into this type of construction where you're using a sheet metal basic structure, then either machine or investment steel cast parts welded together. It is a cheap, inexpensive way to manufacture it, except there's a tremendous amount of know-how and care involved in doing the welding techniques to make sure that you can hold the tolerances. This is a very difficult thing to do in actuality. I think that the Navy and the Army have found out recently how difficult a Mark 19 grenade launcher is to build, because it's built just like this, using the same techniques. But that's basically the reason I made the change on the thing. In this day and age, looking at newer designs, I don't think this is a good idea because the tooling costs are so high. You can actually build weapons, especially in the machine gun market, cheaper, better, by going to numerical control machines and actually machining parts out, because you don't have that tremendously high initial tooling costs. And you have a lot more flexibility in case you have to make a change, and you don't have the assembly problems of welding and all those things. That answer your question?
That certainly does. That's exactly what I was looking for. When did you start to work then on your newest machine gun, your little LMG, your light machine gun?
Well, that's been the last year. And that came about strictly as kind of a personal challenge on it was fostered, I guess, by the problems they were having with the present weapon. Was it the 149, I guess?
249.
Or 249. And it turned out that I thought that 249 had to do the fact that it was tentatively adopted by the United States government, that it was everybody was happy with it and so forth. But in investigating and finding out there were quite a few difficulties and a number of deficiencies. I got a hold of the list of the deficiencies, and I kind of looked at them and went down mentally down how would you solve these things, and came up with that design. And so we thought, well, give it a try. And with that design, I was favoring the use of numerical control machines. In other words, making a design compatible with dropping a part in a numerical control machine and doing as much machine work as possible in one setup, taking advantage of the capabilities of the numerical control machine. And for instance, in that gun, we can get into that a little later, but there's the most complicated part, the receiver, is only about 2 setups in the whole receiver. So that's how that came about. It was kind of a way, well, here's a way of maybe of doing it that would satisfy the user. I knew full well that we're getting started real late in the thing. So that's one of the reasons we've been lately just concentrating on the I guess the most fastidious users of the special forces, and we're working with them on trying to get their needs taken care of and using that basic weapon to do it.
Well, the greatest fans of the Stoner 63 machine gun were the SEALs, and they actually used those in Vietnam, and after all these years are still trying to keep theirs alive, and I understand they have an interest in your light machine gun at the present time.
Well, that's correct. Kind of had a fan club built up there, I guess, and we have demonstrated to them, and they do seem to have pretty good interest in it right now. And there again in that, trying to introduce a few new materials, such as stainless materials that we haven't tried to do before. And they like that because they have the salt water to contend with. And I can see some reasons why they like the particular idea.
One of the themes that comes out of our discussion today, and it might be appropriate wrap-up for the afternoon, it seems that you come to the design of small arms with manufacturing considerations sort of foremost in your mind. So what's available in terms of materials and technology. How have, and I don't know if you can summarize this quickly, but how has that whole environment of materials and production technology changed over the course of the last 30 years?
Well, it's a constant changing thing. Materials, first place, I think as far as mechanisms are concerned, if you want to start breaking out bits and pieces of mechanisms of weapons, there's very little new. In other words, all the basic principles are there. And there's one thing for sure, even a lot of people try it, we haven't managed to change the laws of physics very much. And so therefore, the things that are really left to play with and to, you might say, improve on or change are the materials that are available that come along. Every time there's a new material, it may fit something that, and allow you to do something that you couldn't do before because the material wasn't available. Or even finishes can make quite a difference. And then you take that with new machining techniques or fabrication techniques. There's, in the last, since the M16 was designed, or even this weapon's designed, there's a whole new technology there on manufacturing. That's the reason, like on this last design, I was favoring the NC type machine, because that really is a universal machine. It allows you to put a gun plant together with practically no dedicated machinery, and it used to be unheard of. You had to dedicate all kinds of machines. Just the dies alone in this weapon run up into the hundreds of thousands of dollars, or even literally in millions of dollars of tooling. And you don't have to do that in this machine systems we have now. So it's a combination, I think, of fabrication techniques, of new material that allows you to design new things in the gun field. The gunpowder propellant thing is as old as the hills. We haven't changed that very little, if any, over the last 100 years. We're attempting to change some of the components that we put in the propellants, and into the propellant systems and everything, but that hasn't changed too much. But we're still pushing the bullet down a barrel with high pressure gas, which we've been doing for a long time. But the opportunities come up by the change of materials and manufacturing techniques. Not too many brand new revolutionary ideas.
To what extent has small arms design ceased to be something one individual can do, as opposed to now more and more it seems that design of weapon systems of all sorts are really team efforts? We've gone sort of from the single individual entrepreneur designer, in a sense, the John Browning, the John Guerin, somebody like yourself, to now groups of engineers working together under a team leader. How has that changed in your lifetime, or your experience with this?
Well, I think you've described it pretty well. It has changed quite a bit from an individual effort to a group. I know in my case, I can design a weapon, and I need help when it comes to materials, choosing, for instance, the best plastic or whatever. I might get that from the supplier, the manufacturer of the plastics, but I have to go to some other source to get that. It used to be, if it was wood, there wasn't much argument about that, or if it was steel, there wasn't, there were only a few choices on steel, and you'd use that. But nowadays, when you're trying to take advantage of all these new materials, you have to bring in a lot broader group of people to assist you in selection of materials alone, or whether an idea you have using the material is even practical or not. Like we're looking at a lot of composites now. And these things are fields in themselves if you want to do a good job. One of the things we've been talking about small arms quite a bit. When you get into the larger caliber weapons, you then run into a team situation much quicker, because in the larger caliber weapons you're running into much more serious, I say more serious problem areas in stress analysis and kinematics and everything. They're very unforgiving when you get into the big pieces. While in small arms, just using a little bit of judgment here and there, you can get by with a lot of things. But this ceases to be so when you get into the medium caliber or very high performance weapons. Everything has to be worked out, and the basic designer has got to be backed up with somebody that's really good in finite element analysis and kinematics and so forth. It's probably beyond the scope of any one individual to do a good job on it. And you do see, even in the small arms business, I think a lot of that team thing going on. In my respect, my experience on it is that it's sometimes doesn't work too good. It's almost like a committee trying to design a horse and they come up with a camel type thing. It's a lot easier to put a team together, I think, on a larger system than it is a rifle or a small arms, because every single piece in a small arm affects one or two other pieces, and if you try to designate one area or another in the design and then hope that they all come together, it's a pretty difficult thing to do. We've been able to take in the larger caliber weapons, break down feed mechanisms and bolt mechanisms and buffer mechanisms and give them to individuals and with certain guidelines and let them work that out. Depends a lot, I guess, too, on your resources. But I think the small arms are about the only thing left that you can individually do, but you still, if you want to take advantage of tooling techniques and material techniques, you still have to bring in a lot of expert help. Even the tooling on some of the new weapons I've designed lately, I have to get together one of our tool engineers and say, can we put this on an NC machine? I've got one design where I wouldn't even have tried it 10 years ago because there was no way to cut a cam if you didn't have one of these machines that could give you 3 axes simultaneously. But it was simple once that machine came along and the fellow figured out how to program it, make it just as easy as a straight line. So it's a matter of keeping up, I guess, with techniques that way too, that allows you to go ahead. I think that's going to go on for quite a while, even in our present systems.
How do you create creativity? In a sense of how do you pass on through an organization like Ares or whatever company a particularly talented designer happens to be working for? How do you pass that on to the next generation? Is there any way, or do you just have to hope that somebody comes along and picks that up?
I think there's a lot of luck involved. You can't teach it, in my opinion. You can't by education give this whatever it is to people. Very interesting. I've had a lot of talks with people that are in the business, and it's a very difficult thing to come up with. And unfortunately, depending on the organization, sometimes the people that might have this creativity don't get their chance because of the lack of maybe educational background or whatever it might be. And I had a very interesting talk about this one time to somebody that I consider a real expert, and it was a Dr. Spalding that worked for Oerlikon, who was a German PhD in mechanics that worked in the gun business all of his life and lived through the whole World War II experience in Germany. And tremendously talented guy. And I said, how do you do it? And the Germans got pretty good at this, and turning out novel weapons, and a lot of them during World War II. He said, well, he said one thing, he said, we brought in, this was at Oerlikon, and he says what we did is we brought in a pretty good sized team of Germans after World War II, of designers and support people both in guns and ammunition. And he said what they did in Germany and what they're doing with the management at Oerlikon at the time, they don't do that now, but at the time, he said, we want a gun designer. He said, we look for people very carefully wherever they are, whether they're an engineer or in the shop or wherever, to see if they've got this, whatever it is, knack to design mechanical things. They can visualize and design mechanical things and have this talent. Because we found out a long time ago we couldn't teach it in school. So that just some people have it, some don't, and we don't know why. So we try to find this individual. And according to Spaulding, he said very, very few of their top designers came through schools that were even diploma engineers. He said very few. He says maybe 1 out of 10. And he said what we found has worked best. He says we find this individual and that has this particular capability, and then he says to get people like me. I mean, he was a tremendous mathematician, and he really knew his kinematics, and he had a tremendous, years and years of background. I help him out where he needs it. And we get a stress analyst or something and let him help out where he needs it. But he says, we don't let these people get into the detailed ideas and the design. And he said, that seems to work better than any other system, rather than put it in a great big group of people and say, a committee's going to do this. It really is, we have to put an individual that has these, can visualize a system, and then back him up with the talent he needs. And that was the way they did it. Unfortunately, in a lot of places you can't do that. First of all, they won't let a person run a team like that if he doesn't have a degree. He just never gets the chance. So you can't go out and take a real sharp shop man or something that can build any kind of a gadget you can think of and give him that opportunity. He doesn't fit.
That seems to be what the Soviets have actually done.
Rolling and recording.
The Soviet government, specifically the Ministry of Defense, seems to have done exactly what you're talking about in the case of Kalashnikov. They took him out of a convalescent ward where he had sketched up some interesting designs and put him in an environment where there were many people who could support him. He broke through those barriers simply because somebody said, thou shalt do this, and made it happen. Mm-hmm. But he was lucky in the sense, I believe, that he was given that opportunity. He didn't have the engineering background to complete an entire design to draw it up. Certainly had the skill that was necessary to conceptualize. Mm-hmm. But there are those sort of caste barriers that exist, and I don't know how you get around them.
I did.
You did.
But it ain't easy. No, I can go by my own experience. I haven't any formal education in engineering. I had to quit school as soon as I graduated from high school. I mean, it was a must at the time, and I had great ideas going to engineering school, but circumstances took care of that. And I got into a kind of a pseudo-engineering job in the aircraft business by getting into the lofting, and which became drafting and things like that, and a little more complicated than drafting. And then also, I was after I got out of the service, my job was no longer there, and I was faced up with a dilemma of what to do. And I hadn't had an engineering degree, but I'd been doing some engineering work. But I had this little caste problem, and timing and luck has a lot to do with it. I ran into an individual who was very much like myself, that, I could dream up new gadgets and things, but he had an engineering degree, but was in a completely foreign field. And I had to do, I did some work for him on the side, and he was impressed. So he said, I've got this new company I'm going to go to work for as their chief engineer. And he said, I don't have any way of getting you in the engineering department. It had about 25 people or 30 in the engineering department. But he said, can you hold your own in a machine shop, specifically a model shop building prototypes? And I says, yeah, I've worked around shops a bit. I think I can. He says, if you can do that, when we get an opportunity, he says, I'll get you in there. So anyway, I worked in this shop for, I think, about 3 years before the opportunity came along. And the fellow was true to his word. And he took me up and introduced me to the head engineer. And the head engineer, which was one of the old-timer engineers, took one look at me, and he knew me because we were a rather small company. And he said, what do you mean taking him up here? He's not a graduate engineer. He said this right in front of me. He says, the fact is, I don't know what you mean bringing people like this up and expecting me to use them. And so the head man says, well, you're going to. And he says, I promised this fellow an opportunity, and you're going to do it. So due to the fact I had a lot of shop experience, it gave me an advantage over almost everybody there, because none of them, the engineers are not taught shop in this country. So I had that going for me, and I used that up to the hilt. So they put me in a product engineering or production engineering department. And I got quite a bit of experience in there, but it was easy for me because I could see where their problems were coming from the shop or interpreting prints or whatever. So I didn't have any trouble with that job at all, but I really wanted to do design work. So I did on my own, I did some design work for them. It turned out to be a whole new line for the company. And the head man was impressed enough, he said, you want to be a designer? And I said, I'm going to get out of this production engineering. He says, okay, you've got it. He put me underneath the head designer. But the interesting thing on that was that when I went into that department, the guy that said he didn't want me turned out to be the motherly type. He was a teacher by heart and used to spend endless hours with me teaching me how to solve problems engineering-wise that he knew I didn't know how to do them. But he'd take the time. And turned out we became very good friends and all, but he was the guy who was very, very blunt, German type, and he said, you can't do it, I won't have you here. And he ended up, we were good friends, and then I got that experience in that company, and luckily it was a company that had a broad field in aircraft equipment. And I got a chance to do everything the time I was over with, and was a designer there for years until I went out on my own and quit. But I know what the problems are and the animosity and everything in there, and it's justified in a lot of cases. I also had the experience of working with graduate engineers that couldn't hold their jobs because they had no mechanical aptitude whatsoever, and they just got in trouble, and they couldn't design anything. It was just like Dr. Spaulding told me. He says, I can help out any engineer design something, but he says, I absolutely can't design anything. He says, I know my limitation. But he says, I can sure help out if you've got a problem. But that was a lucky thing for me. I got that break, quite a few years back. And then once I got established in that thing, nobody ever asked me if I'd graduated from engineering school or not. But it took some doing. It took a lot of years. And the most valuable thing that I found out was having that shop experience for several years where I had to make a living doing it. It was a tough thing. The jobs we had, to give you an idea, was building prototype cameras and automatic processing and developing equipment, small electric motors about yay long, actuating systems, a lot of very small little intricate pieces of machinery. It took a lot of skill to do. So it gave me a good background. Building a gun part wasn't a big deal after you worked on some of those things. It was rather an easy thing to do. But, it was a matter of luck and timing and being in the right place at the right time. But it is a difficult thing to try to find the right person you want to pass stuff on to or whatever. You don't get that opportunity very often. You'd like to, but I know my experience has been that it's very, very difficult. Find the right guy and have the time and, the opportunity to do it.
Thank you. I think that'll do it for today.
So let's hold this, sorry, just a little wider. What do you,
That's
that's
unless I
it.
move the camera, or we slide things in a little tighter. Is that too tight?
Let's see, we lose the,
They're going to get closer when you
yeah.
get...
Tape is rolling and recording.
The Stoner 63 weapon system was designed to take the basic components for the receiver operating mechanism and the bolt assembly and interchange it through a series of configurations. Before us we have essentially a complete Stoner 63 system ranging from a folding stock carbine variant through a tripod-mounted medium machine gun. All of these weapons fire the same cartridge, and all of the magazine weapons use the same magazine. Okay, let's start up there in that corner
Go
now.
up him.
Okay. Okay, and if you stop, and then when I stop, then we can move to the next one. The Stoner 63 carbine came in two stock configurations. Here we show a metal folding stock which folds under the weapon. There was also a version with a side folding synthetic material or plastic stock assembly. Okay. Okay, stop right there. As a squad automatic weapon, Stoner created a version which used the basic rifle mechanism inverted from the standard rifle position and with a magazine fitted into the top of the weapon. This weapon looks a great deal like the Bren gun and older British squad automatic support weapons. Note also that this weapon has a heavier weight barrel, and that barrel allows the weapon to be fired at a more sustained rate of fire. Okay, now go back down again and get that one that's right in front. That's perfect. For vehicular application in turrets and in coaxial mountings in armored cars and light tanks, the Stoner 63 could also be fired with a electric trigger, and in this model it does not have the stock but has a solenoid in the place of where the stock would mount. The U.S. Navy SEAL Air Land Force, let me do that over again. The U.S. Navy Sea Air Land Force, called the SEALs, liked this particular model a great deal since it had a box magazine attached to the weapon and used a belt feeding mechanism. The box held 100 rounds of belted 5.56 millimeter ammunition. The rifle version of the Stoner 63 has a longer barrel than the carbine, but it has a barrel which can be easily interchanged with the carbine. The distinguishing feature is simply the length of the barrel.
Can we do this one again? Is that a problem?
You want to do that one again?
Yeah, I just... the lens further.
This one here?
Yeah.
The Stoner 63 rifle is essentially the same weapon as the carbine, except that it has a slightly longer barrel. Its barrel can be interchanged very easily with the barrel which is mounted on the carbine. And the final member of the Stoner 63 weapon system shown here is the belt-fed medium machine gun. It is simply, as the other belt-fed machine guns, with the exception that the stock has been removed, and it is mounted on a special adapter that allows it to be put on the M122 tripod.